All right, today we got overlapping triangles. So we're kind of taking everything that we've done in the past with proving triangles congruent, and then we're just looking at triangles that have either maybe common sides or common angles. And usually they're going to be overlapping on top of one another here. So in each diagram, given that the triangles are congruent, identify their common side or angle. So I'm going to look here, they have ADC, and then they also have BCD. Oops. So anyways, you have those two triangles. So here in the middle, they have that overlapping side, so that would be DC. You would put the segment DC right there. All right, and sometimes I like to highlight the triangles because I don't know if they're talking about these little tiny triangles or large triangles. So it's always a good idea to kind of draw on top of the overlapping triangles. So this one here, you got K and J. So that'd be this triangle right here, and that matches up with KML. Right, and they don't actually have a full common side, but they have this common angle here in the middle. So we're going to say that's angle K, or you could call it, JKL. That's all I'm going to put there for that one right there. All right, this next one here, you got UXV. See, so initially when I looked at this one here, I was thinking of a different triangle. That's why you got to always identify. And then you got VW and then U. All right, so obviously they have this side right here in the middle, so that'd be UV. Those are congruent. After that, this one's a little bit more straightforward. Got a shared side right down the middle right there, so that'd be TR. Segment TR. That one's pretty straightforward there. So I always like when they give us that type of problem right there. So this one, same thing here. Obviously, EG's got to be your common side. Here's another one that kind of looks weird here, so I need to go and look through carefully. So you have YNI, and then we got YPZ. All right, so it looks like they don't have any full common sides, but they do have that common angle there, so we'll say angle Y for that one. That's really all you got to do in that little section there. Okay, so after that, now that we got practice with that, well, now we're going to identify those common sides or identify those common angles, and then we're going to go and prove that the two triangles are going to be congruent. So we're looking for overlapping sides or angles, and then we'll say why they are congruent. So given that you have, and this is already marked, ZW is congruent to XY, you also have the angles Y, X, W, I guess those are right angles, and then I guess Z, W, X right there, those are right angles. And then it looks here like you have this common side between these two overall triangles that I have highlighted right there. So we will say, okay, so we got to identify first of all the triangles and then say why they're congruent. So I'm going to start here with Z, W, and then X. So triangle ZWX is congruent to the other triangle. Now I got to go in that corresponding order here. So I got to start out with that top angle there, Y, and then X, and then W. All right, and then they do have that overlapping side in the middle there. So you have side, angle, side, side, angle, side on both of those right there. So they're congruent because of side, angle, side on that one. And each one of these after this is kind of a repetitive and maybe slightly different version. So let's see here. Now it looks, okay, I kind of get this here. You got, given that ABC is congruent to DCB, so that means these giant angles right here are congruent to one another. Then I bet you're going to have two little mini angles here. What do we got? CBD. Yep, so you got a little mini angle and then a little mini angle right there. Okay, so therefore those triangles are congruent. Looks like you have a shared side right down the middle. So I think what they're talking about is maybe this triangle right here that I have highlighted in blue, and then this triangle right here highlighted in red. And then once again you have that shared side in the middle. So it looks like you have side, angle, side in this case. Or I'm sorry, actually, no, I'm backwards here. Angle, side, angle. angle, side, angle. Sometimes I tell my students here, sometimes these are kind of hard to visualize, so I draw them separately. So if you want to draw the two triangles separately, go for that right there. So they said like you had the big angles congruent, you had the little angles also congruent, and then we had that shared side right down the middle. So that'd be angle, side, angle. So let's get the order right. So we're going to go triangle A, I guess ABC. And then that'll be congruent to, make sure you go in the corresponding order. So we got to start with D over here on this side. So D, C, and then B. And therefore, those two triangles are congruent. Okay. Next one here, what do we got? Looks like given EJ is perpendicular to FK. So looks like you're going to have some type of corresponding angles being congruent right there. So I'm going to go ahead and mark those. Looks like you're also going to have these other corresponding angles down here congruent to one another. So I'll mark that as well because you got the other set of parallel lines. And then they also tell us that EG is congruent to HF. And that's kind of hard to mark, I guess, on this thing. You know, if you wanted to do something like this, you could mark it congruent, I guess, kind of like that. But it's really not a fancy way to do that, so just kind of keep that in mind. But anyways, that's a side. That's between our two sets of corresponding angles. So that would be angle, side, angle for this one. Okay, and then I'll write triangle J, I guess JEG is congruent, and then I got to go in that same corresponding order, so I got to start with K, so triangle K, and then F, and then H, right there. You got some of your congruent triangles there. That one's kind of weird because it actually doesn't have a common side or a common angle on that one, so, but they're kind of, the two triangles are stacked on one another, so you just got to be kind of careful on that. So let's see what we got here. LP is congruent to LO, okay, and then we also have P M is congruent to ON. So if we look here at the triangles that they're talking about, I think they're talking about this big giant triangle right here. So notice you got that LP, and then that's going to be congruent to the LO of the other triangle. All right, and then since you have these other little pieces right here that are congruent, when you add two congruent things to, you know, if you have like you know, the one tick plus, there's really not a good way to write it here, but you have the one tick plus a two tick right there, well then that's congruent to the other one tick and the two ticks right there. So these two sides all together are going to be congruent, so these longer sides will be congruent. Then you have a shared angle in the middle. Angle L is shared, so we'll write angle L is congruent to angle L, I guess. And then right then and there you have enough to say that the two triangles are congruent because of side, angle, side. Now if you don't see that, once again, this is probably a good one where you could draw everything off to the side here. So you had the shorter side, you had the longer side, and then here's angle L. And then I'm going to draw the other triangle kind of going in the other direction. So you're going to have LP, you're going to have the longer side, and then you're going to have angle L right there. So that'd be side, angle, side. So let's get the correct order going. Get something to start with angle N, doesn't matter, so NLP is congruent, and then let's go, I guess MLO. There you go. All right, a couple more here. Let's see what's going on. Now these right here, this one, remember this being kind of tricky from last year here. So they give us that DE is congruent to FG. Oh, okay, so those are those little sides right there. And then AC is congruent to CB, and then EC is congruent to FC. So, I mean, obviously there's only there's one triangle here in the middle, but as far as two triangles, I think we're going to be dealing with this triangle over here, AFD, and then guess we're going to have to go with BEG right there. Okay, so we can say kind of like the last one here, the sum of two sides is congruent to the sum of the other two sides there. So we've got that going for us. So I'm going to mark those congruents separately, just so we can kind of visualize kind of what's going on. right? And then you got, I guess you do have like this shared side thing here in the middle. I guess I'm going to mark it with 4 ticks. So you got 1 plus 4 equals another 1 plus 4 for the ticks. So we can eventually go and say that these two bottom sides are going to be congruent to one another. But then they don't really tell us anything else. So we're going to have to think back to what this figure looks like here. So I want you to focus on this here. If you look at just this little miniature triangle right here, we notice that you have two sides that are marked congruent. So therefore, it's an isosceles triangle. And then we got to keep in mind, hey, isosceles triangles have congruent base angles. So these little angles right here, we can go ahead and actually mark them congruent to one another there. So that would give us side angle side here in this case, that these two triangles are congruent. So this one's kind of tricky. This one's not an easy one to grasp, and that's why I'm drawing them separately off to the side. So anyways, now that we have everything kind of organized, I'll go back and say, let's say ADF is congruent to triangle BGE right there. So yeah, kind of a trickier one there on that one, so you gotta be careful. Once again, we use the idea that you have an isosceles triangle right here in the middle, so therefore you have congruent base angles, and then that helps us finish this one up. Okay. This next one here is actually really similar to number 2. Notice that you have a couple of these angles that are given to you. So we have, where are we, YUV. So this little angle here is congruent to XVU. All right, so those two little angles are going to be congruent to one another. Now they also tell us, I think, that the big overall angles are congruent. So what do we have here? We have WUV. Yep, so that would be the giant angle that you're dealing with right there, is congruent to the other giant angle right there. So it's kind of confusing when you have a bunch of markings in the same spots there. So I believe what triangles that they're going to be talking about are these two right here. So that would be UVX and also VUY right there. So we're talking about those two triangles. So I'm going to redraw those off to the side, kind of like what I just did before. You had the bigger angles congruent, you had the smaller angles congruent. Then it looks like you're going to have a shared side right there in the middle. So let me just get this all color-coded. And then we can move along here. So little angle, bigger angle, shared side. So anyways, those are going to be congruent because of angle, side, angle, because you have the included side. So we can therefore say that triangle, I guess we'll go UXV, is congruent to the other triangle. Now I got to go in that corresponding order, so I got to start with V. So I'll go VU. Wait. Oh, I'm sorry. Actually, I'm going in the wrong order here. I got to go VY. My bad. VY, and then U. There we go. Oh, and I need my triangle symbol. But anyways, there you go. There's a couple of examples of the overlapping triangles and just determining whether they're congruent or not. So they're kind of tricky there. Draw them separately if you need. Now let's tackle this proof that we got here dealing with the same type of stuff, except it's in the proof format. So we're going to actually write out the full proof here. So given that you have these two segments, RU is congruent to TS, that is not marked, so we need to go mark that ourselves. And then RUT and then UTS are right angles. And then V is the midpoint of US. Prove that the triangles RUT is congruent to STU right there. So actually, this is kind of interesting because I'm looking through this proof right here. Actually, we have a shared side here in the middle, so actually I don't even think you need to worry about the midpoint thing going on right there. I'm looking here at this proof because you got these overall these two triangles here, and you got side angle side for both of them there. So actually, I don't even think we need to use the fact that V is the midpoint of US. So I mean, we could use it but not necessarily going to help us here. So anyways, first thing here, we'll write given. I like how they said UT is congruent to TU. Now, this right here kind of looks weird, but this is actually the reflexive property. They just wrote it in the corresponding order. They're saying UT is congruent to TU right there. So it's actually technically reflexive because those are the same. All right, and then since RUT and UTS are right angles, we're going to say that they are congruent to one another. So RUT is congruent to UTS. And I guess I need to put my angle symbol there. All right angles are congruent. Therefore, your two triangles, and I'm going to go in the same order they wrote up there at the proof line right there. So RUT is congruent to the triangle STU. All right, and that is because of side angle side. There you go. So once again, we didn't need that V as a midpoint of US. That really didn't help us out at all. So anyways, there you go. There's your overlapping triangles. Really not anything new. It's just, it looks different. We just need to know how to recognize them and some strategies on when they're overlapping. You know, sometimes it's good to draw them separately, kind of like I just did. So anyways, that's it.